Imagine a world of giants, ruled for millions of years. Then, in a heartbeat, silence. We sought the answer not in their bones, but in a microscopic mystery hidden within a quiet Italian hillside. This is the moment the world's 100-million-year reign changed forever, the ultimate Great Reset. Our journey begins in the Apennine Mountains of Italy, near the medieval town of Gubbio. This landscape is a masterpiece of geology, a place where the Earth's crust has folded and uplifted, exposing millions of years of history. Here, the limestone cliffs tell a story of an ancient deep sea that once teemed with life long before these mountains existed. In the 1970s, geologist Walter Alvarez arrived at these cliffs to study the magnetic orientation of the rocks. To determine the age of these layers, he utilized the ultimate biological clock, foraminifera. These are tiny, single-celled marine organisms, or forams, that float in the upper ocean. When they die, their calcium-rich shells sink to the abyss, eventually compressing into the very stone today. Under the microscope, the forams of the late Cretaceous are magnificent. They are large, ornate, and incredibly diverse. For thousands of vertical feet of limestone, these creatures are markers of geologic time. But as the investigation moved upward through the layers, climbing forward in time, it encountered a geological anomaly that defied conventional logic. Suddenly, the large, diverse forams simply stop. It wasn't a gradual decline or a slow fading of species. It was a total, synchronized disappearance. Directly above the white Cretaceous limestone sat a thin, dark ribbon of clay, no thicker than a human finger. And above that clay, the world had changed. The diverse forams were gone, replaced by a few tiny, stunted species. It was as if the ocean's life support system had been unplugged in an instant. This is the KPG boundary. In the field of geology, where change is usually measured in the slow crawl of millions of years, this transition was terrifyingly fast. This centimeter-thick layer of clay represented a global catastrophe. A great dying that occurred at the exact same moment the dinosaurs vanished from the fossil record on land. What could cause such a total, instantaneous collapse of life across both land and sea? Was it a massive volcanic eruption? A sudden change in sea level? Or something far more violent originating from beyond our atmosphere? At this stage, the clay remained a silent witness. It held the secret to the end of an era. To find the answer, the investigation had to look beyond the fossils and into the very chemistry of the Earth. The smoking gun was waiting to be found. The thin line of clay at Gubbio was the first clue that the fate of the Mesozoic was decided not by the slow pace of evolution, but by a single, catastrophic day that remade the planet. With the discovery of the silent clay layer at Gubbio, the investigation shifted from the visual to the chemical. To understand the duration of this extinction, Walter Alvarez sought the expertise of his father, the Nobel Prize-winning physicist Luis Alvarez. Together, they looked for a way to measure how much time was captured within that dark ribbon of Earth's history. They turned their attention to a rare element, iridium. In the story of our planet, iridium is a ghost. As a siderophile, or iron-loving element, most of the Earth's original iridium sank deep into the molten core during the planet's formation, leaving the crust nearly depleted. However, iridium remains constant in the debris of the solar system. It arrives on Earth in a steady, invisible rain of cosmic dust from space. The Alvarezes reasoned that if the clay layer took thousands of years to form, it would contain a detectable amount of this cosmic dust. But when the results came back from the lab, the data didn't just speak, it shouted. The concentration of iridium wasn't just slightly elevated. It was 30 times higher than the normal levels found in the surrounding rock. To ensure this wasn't a local anomaly in Italy, the team tested the KPG boundary in Denmark and New Zealand. The results were identical. Across the globe, at the exact moment the Mesozoic ended, the Earth was blanketed in a layer of extraterrestrial stardust. This led to a shocking hypothesis, the asteroid theory. To distribute that much iridium globally, the source had to be a giant, an asteroid 10 kilometers in diameter, or about the size of Mount Everest. "66 million years ago, this mountain of rock, weighing hundreds of billions of tons, slammed into the planet at 20 times the speed of a bullet. The clay at Gubbio was no longer just dirt. It was the settled ash of a world-ending impact that remade the Earth in a single day. The discovery of iridium was a monumental breakthrough, but in the early 1980s, it was not yet a verdict. The scientific community remained deeply skeptical. Many geologists favored a different culprit: massive volcanic eruptions in India known as the Deccan Traps. They argued that deep-seated volcanism could bring iridium from the Earth's mantle to the surface over hundreds of thousands of years. To prove an impact had occurred, the investigation needed more than just chemistry. It needed a physical, smoking gun, a signature that no volcano on Earth could produce. That evidence was found in a mineral as common as beach sand: quartz. Under a high-powered microscope, geologists began to notice something extraordinary in the grains of quartz retrieved from the KPG boundary. These grains were not smooth. Instead, they were scarred with microscopic, crisscrossing lines, known as planar deformation features. This is what scientists call shocked quartz. The physics behind this deformation is profound. Quartz is incredibly stable. The heat and pressure of even the most violent volcanic eruptions are insufficient to alter its crystal lattice in this way. These parallel shock lines are only forged by a sudden, monstrous pulse of energy. A shock wave so powerful it physically displaces the atoms within the mineral. In our world, this signature is only created by two things: the detonation of a nuclear weapon or the hypersonic impact of an asteroid. This discovery effectively silenced the volcanic debate. The smoking gun was now in hand, confirming that a high-energy explosion, not a slow eruption, had occurred 66 million years ago. But the mystery had one final hurdle. Where was the crater? Clue further intensified along the coastlines of the Americas. In places like Texas and Haiti, researchers found thick deposits of spherules, tiny glass beads formed when vaporized rock cooled in midair. Even more telling were the massive, jumbled layers of boulders near the Brazos River in Texas. evidence of a colossal tsunami that had ripped through the Gulf of Mexico. The trail of debris was growing thicker and more violent, pointing the scientific detectives toward a single hidden location: the Yucatan Peninsula. The evidence was no longer just a thin line of clay. It was a map of a crime scene on a planetary scale. For years, the asteroid hypothesis faced one final glaring omission: the crater itself. If an object the size of Mount Everest had struck the Earth, it should have left a scar 200 kilometers wide. The search eventually led to the Yucatan Peninsula in Mexico, where gravity measurements revealed a massive circular structure buried beneath hundreds of meters of sediment. This was Chicxulub, the ground zero of the Mesozoic apocalypse. The discovery allowed scientists to reconstruct the most violent 24 hours in the history of complex life. The event began not with a slow decline, but with a flash of light brighter than 1,000 suns. The asteroid slammed into the shallow carbonate shelf of the Yucatan at 60,000 kilometers per hour. The energy released was equivalent to 100 million nuclear bombs detonating at a single point. In an instant, the impact site was transformed into a vacuum of white-hot plasma, vaporizing the asteroid in cubic kilometers of the Earth's crust. The first wave of destruction was a thermal pulse. Within seconds, the heat ignited everything within a 1,000-mile radius. But the true horror lay in the ejecta curtain. Billions of tons of vaporized rock were blasted upward, escaping the atmosphere into suborbital space. As this debris fell back to Earth, friction with the atmosphere turned the sky into a global broiler. Across the planet, the air temperature skyrocketed, reaching hundreds of degrees. On the ground, the great forests of the Cretaceous spontaneously ignited. While the fires raged, the oceans reacted with equal fury. The displacement of the seafloor triggered megatsunamis, walls of water over 100 meters high that raced across the Gulf of Mexico at the speed of a jet. In places like the Brazos River in Texas, geologists found the evidence. Massive, jumbled boulders and deep-sea sediments ripped from the abyss and dumped hundreds of miles inland. By the end of the first day, the initial firestorm began to fade, only to be replaced by a suffocating darkness. The impact had struck a region rich in gypsum and sulfur. As these minerals vaporized, they filled the atmosphere with an opaque aerosol of dust and sulfuric acid. The sun was obliterated. As the first 24 hours came to a close, the day of fire transitioned into a nuclear winter that would last for months. Photosynthesis, the very engine of life, ground to a halt. The giants of the Mesozoic, who had survived the heat and the waves, now faced a world without light and a food chain that had simply ceased to exist. Beyond the initial chaos, a more insidious killer took hold, a global shroud of darkness. Trillions of tons of debris turned the atmosphere into a wall that no sunlight could pierce. Photosynthesis, the process that powers nearly every food chain on Earth, ground to a halt. As the forests of the Cretaceous perished, the world entered a period of biological stagnation known as the impact winter. Evidence of this botanical collapse is etched into the fossil record of the Hell Creek Formation in North Dakota. By analyzing fossilized pollen and spores, paleobotanists have identified a phenomenon called the fern spike. Before the impact, the landscape was a mosaic of diverse flowering plants and towering conifers. Immediately above the KPG boundary, that diversity vanishes. For a brief geological moment, the world belonged almost exclusively to ferns. Ferns are pioneer species. Their hardy spores can germinate in a barren, ash-covered wasteland where nothing else can grow. This spike in fern spores is the silent signature of a planet in recovery. The collapse of the plant kingdom triggered a domino effect. The massive herbivores, the triceratops and hadrosaurs, who required hundreds of pounds of fresh vegetation daily, were the first to starve. Consequently, the apex predators, like the Tyrannosaurus rex, who preyed upon them, followed into oblivion. Yet, amid the ash, there were survivors. The survivors were predominantly creatures that lived in burrows, swamps, or deep water. Environments that acted as heat shields during the initial thermal pulse. Among them were our own ancestors, small, shrew-like mammals. These creatures possessed several critical advantages. Their small size meant they required very little food. Being omnivores, they could scavenge on insects, roots, and decaying organic matter in a world where fresh greenery was non-existent. Furthermore, their high reproductive rates allowed their populations to bounce back rapidly once the skies finally cleared. This was the ultimate Great Reset. The extinction of the dinosaurs vacated every major ecological niche on land. As the sun returned and the fern-covered barrens began to evolve back into diverse forests, these tiny mammals emerged from their burrows into a world without predators. The age of mammals had begun. As we look back at the jagged cliffs of Gubbio, we see a profound truth. The history of life is shaped not by steady progress, but by cataclysm. The day the Mesozoic died was not merely the end of the dinosaurs. It was the crucible of the modern world. This thin ribbon of iridium and ash reminds us that Earth is part of a violent cosmos, where survival is not granted to the strongest, but to the resilient and the adaptable. The asteroid was a tragedy for the giants of the past. but it was the essential doorway for everything that followed. Today, every bird in the sky and every mammal in the forest is a living testament to that day of fire 66 million years ago. If you found this exploration of our planet's history meaningful, please subscribe to our channel. Together, let us continue to uncover the remarkable secrets of the deep past.